Hello chemistry students. In this video I'm going to go over the solubility notes. So let's go through this. This is all about if you know that something will dissolve, exactly how much of it can dissolve. So solubility is defined as the maximum amount of solute that can dissolve in a certain amount of solution. In the notes that we're doing today, and in most cases where you're given solubility graphs, that will be in grams of solute per 100 grams of solvent, and the solvent is usually water. Alright, so the factors that affect solubility are the nature of the solute, the nature of the solvent. Think back to the polar versus nonpolar kind of thing. And then also temperature affects the solubility of substances. So solids tend to have increasing solubility with increasing temperature, while gases tend to have decreasing solubility with increasing temperature. That's why your soda goes flat faster when it's left out in room temperature or in the heat in your car or something, instead of in a refrigerator. Alright, so some things that affect the rate of solution. By the way, dissolution is another term that just means dissolving. So some of the ways you can increase the rate of dissolving for solids anyways is to shake or stir to increase the temperature. That's why you probably add your sugar to your sweet tea when it's the tea's still hot. And then increase the surface area, so crushed or powdered sugar dissolves much faster than cubes of sugar, for example. Alright, gases are a little bit different. So for gases, increase in temperature causes less gas to dissolve in the water. That's another example of that is fish kills can happen when temperatures get too high, because that lowers the dissolved oxygen content in the water. Also for gases, solubility increases as external pressure increases. Henry's law says that solubility of a gas is directly proportional to temperature. So when you're bottling soft drinks, the way that they get all that carbon dioxide to dissolve is they increase the pressure of the carbon dioxide above the mixture, and then that gas dissolves into the soda. And then when you open the soda, you see the effervescence, which is the rapid escape of the gas from the liquid that it's dissolved in. So we're going to look at solubility curves now, and the solubility curve is going to show you the temperature on the x-axis and the solubility on the y-axis, and that solubility is going to be in grams of solute per 100 grams of water. Alright, so here's an example solubility curve, and this is probably very similar to any solubility curve you might encounter. Now, let's just take an example here, let's look at the axes first. That's always a great idea when you're interpreting graphs on tests or anything. So the temperature is on the x-axis, and the grams of solute per 100 grams of water is on the y-axis. They also tell us in the key here we have gases and solids, and you can notice gases decrease in solubility as temperature increases, and solids increase in solubility as temperature increases. And some solids increase a lot, like KNO3, and some solids don't change a lot, like sodium chloride, NaCl. So here's a for example. After you add 37 grams of sodium chloride to 100 milliliters of tap water. By the way, 100 milliliters of tap water would be about 100 grams of tap water, because the density of water is 1 gram per milliliter. No more will dissolve, and we're probably talking about room temperature, about 20 degrees Celsius, where you would have 37 grams of sodium chloride dissolving. Alright, so let's look at some examples here. So our first one, we're going to start off with how much ammonium chloride, NH4Cl, will dissolve in 100 grams of water at 65 degrees Celsius. So we're going to find the line on the graph for ammonium chloride. So here it is, NH4Cl. Then on the x-axis, we're going to find 65 degrees Celsius. So 65 would be exactly halfway between 60 and 70. So we're going to follow that up here and go up until you get to the line for NH4Cl, and go over to the y-axis. So we located this here, and then we're going to track over to the y-axis, and when you do that you get about 69, or excuse me, 59, or maybe 58 grams of NH4Cl. So, and that's how much will dissolve in 100 grams of water at 65 degrees Celsius. Alright, so give these example problems a try, pause the video, and then come back to it, and you'll be able to answer or see if your answers were correct. Alright, so here are the correct answers, and as long as you were within 1 or 2 grams, each of these will be fine. On the last problem, it was kind of a trick because they said 200 grams of water instead of 100 grams of water, so the solubility would be twice as much if you're dealing with twice as much water. Alright, let's talk about determining whether or not solutions are saturated using the solubility curve. So let's just recall a couple of definitions here. So saturated means that the solution has as much solute as possible dissolved. If you added more, it wouldn't dissolve. And that unsaturated solutions have room left for more solute to dissolve. So in the solubility curve graph on the previous slide, the line represents a saturated solution. If you're below the line, it would be unsaturated, and if you were above the line, it would be supersaturated. So let's talk about an example with some KNO3 at 45 degrees Celsius. So if we look back at the solubility graph says that at 45 degrees Celsius, about 75 grams of KNO3 can dissolve. So that's a saturated solution. If I dissolved 40 grams of KNO3, I would make an unsaturated solution because I'm below the maximum solubility of potassium nitrate. However, if I tried to dissolve 100 grams of potassium nitrate, I'd only get, at that temperature anyways, I'd only get 75 grams of it to dissolve. Now, if you're like, well, wait, how do I make a supersaturated solution? Well, you have to make a saturated solution at a higher temperature and then cool it down, and temporarily that extra solute will stay dissolved, but then eventually it will crystallize out of and leave the solution as a solid. So here's a few example problems. Pause the video, give yourself a moment to work through those, and then unpause the video, play it, and see if you got them right. Alright, so here are the answers. So the first example, if you find the KClO3, you will see that 12 grams could dissolve. You only dissolve 5 grams, so that is below the solubility, that is unsaturated. Add the temperature and conditions for the next one, 85 grams could dissolve, and that would make a saturated solution. I believe that was the KNO3. I have to go back and look. Yep. And then the last one was NaCl. So at the temperature given, 39 grams could dissolve. You tried to dissolve 50, so that means that not all of it would dissolve. 11 grams would be left undissolved, and that solid would settle to the bottom of the container. Thanks for watching.